Hello, statistics class. Unfortunately, my son is coughing up a storm right now, and so I'm best to keep him home. So unfortunately, it is my turn to stay home with him. So I'm going to give you an example here of a confidence interval again, give you one more look at it, and then you can go practice it on Sapling, where we usually have our homework assignment. But I wanted to show you one more time, walk you through the steps nice and slow, and hopefully as clear as possible. All right? So we're doing a confidence interval here. So the basic idea is let me get a pen here. We take a sample, right? And from our sample, we get a p hat. Okay? And we know that p hat isn't perfect. That's our point estimator. That isn't perfect, so we add and subtract the margin of error. Now your margin of error is made up of two pieces. All right, the margin of error has the z star. All right, there's your z star. That determines the confidence level that we are doing it, times how many standard deviations you're going out, times the standard deviation, which we are now calling a standard error because it's coming from a sample. All right, plus or minus our point estimator, which is p hat. All right, and the standard error is the square root of p times 1 minus p, or q, divided by our sample size, times z star plus or minus, and then p hat in the front. So there is our full formula for a confidence interval. All right, let's do one. So here's my scenario. Mr. Bolt's kids go to the new elementary school, Hedetta Elementary on Church Avenue. Church Avenue is a pretty busy street, though, and people speed a lot. Bolt's getting tired of this, so I want to estimate the proportion of drivers that are actually speeding. So I wait by the school with my radar gun. There it is. All right, and I track 70 cars. 25 of them are speeding. Create a confidence interval for the true proportion of cars that are speeding on Church Avenue. All right, so my point estimator, p hat, is 25 out of 70. 25 out of 70 people are speeding. If we want to get that as a decimal, 25 out of 70 is roughly 36%. Let's call that 0.36, I suppose. My standard error is equal to the square root. I'm actually going to write this slightly differently this time. So when you do your practice problems on Sapling, they actually write this a little bit differently. So the denominator is going to be 70, right? Because we have 70 people. The numerator, they actually write it this way. This is kind of interesting. I don't know if this will be more clear or less clear. It is p times 1 minus p, right? Well, p is 25 out of 70. Let me zoom in on that just a little bit, make it a little bit bigger. All right, that's 25 out of 70 times q. Well, yeah, it is 1 minus p, but it's the other half of that 25 out of 70. So sometimes you'll see this written as, what was that, 45 out of 70? All right, so yeah, 45 and 25 make 70, right? Yeah. The book writes it that way sometimes. I'm hoping you can see that that is p and 1 minus p. But then you can type that in and get your standard error. So let me do that. So we have the square root of 25 divided by 70 times 45 divided by 70 and then divided by 70 again. So 0.057 is our standard error. All right, so we'll use that now to create our confidence interval. All right, so let's do a 95% one first. That's usually the most popular one, and I think your practice assignment uses the 95 a whole bunch. So we'll do that 0.36. Let me use a little bit more accuracy, actually. It was 0.357, wasn't it? Let's use a little bit more. 357 plus or minus. All right, a 95% confidence interval. It is roughly 2. I want to make it a bit more precise since I want 3 decimal accuracy. It's actually 1.96. Okay? Now, for the work we do in class, I am certainly okay if you use 2, but word of warning on your practice on sapling for your homework and everything, it wants you to use the 1.96. But hopefully you can see that is essentially 2. We're just being a bit more accurate. Times our standard error, which was 0.057. All right, so we just got to type that in now. We'll have 0.357 plus or minus. Let's grab that margin of error, 1.96 times 0.057, 0.112. All right, just a quick reminder. This is your point estimator, and this is your margin of error. Okay, we've got it all nice and simplified there. So now let's add and subtract. So 0.357 minus 0.112 is 0.245, comma, and now 0.357 plus 0.112, which is 0.469. All right, so there we have our confidence interval. I can now write a sentence here that says I am 95% confident the true proportion of drivers that are speeding on Church Avenue is between, all right, 24.5% and 46.9%. There we go. Now, again, I'm okay if you use either the decimals or the percents. Just make sure you don't get them mixed up. I think Sapling asks for mostly the decimals, though, oftentimes. Alrighty, so there's a quick overview of the confidence interval one more time. Head on over to Clever and then to Sapling and try out those practice problems I have for you. Finish them up in class, finish them after at home if you need to, but that can become a homework assignment if you don't finish it in class. Good luck.